Hi, everyone. A very warm welcome. It's a pleasure to have you all here for this very exciting session. The topic of today's webinar is Elevate Your 4G, 5G Network Testing with AutoRAN, Amantya's Test Automation Framework. I am Rohina Chawla, and I'll be moderating today's session. A few points before we begin. We will be sharing a recording of the webinar with you all to revisit at your convenience and to share ahead. Also, we recommend that you use headphones for a better viewing experience. Lastly, if you have any questions or clarifications during the session, please park them in the Q&A section and we shall take them up at the end. Today's webinar is a deep dive into network testing. It features our in-house expert sharing some valuable insights on the topic. He will also take us through a demonstration of Amantya's latest innovation, AutoRAN, and explain how it adds immense value to RAN network testing. Just to give you a brief overview of the testing framework, AutoRAN is a user-friendly test automation framework that uses real UEs to provide RAN OEMs, RAN stack vendors, small cell manufacturers, chip vendors, and MNOs with a scalable testing solution. It closely mimics real-life deployment scenarios and identifies issues early in the product lifecycle. To tell you more about Amantya's groundbreaking innovation and share his insights on 4G, 5G network testing, joining us today is Amantya's leading 5G expert, Indranil Deb. I'll quickly introduce Indranil before we begin the session. Indranil is the AVP Engineering at Amantya Technologies. He is a seasoned expert in the test automation domain and is closely involved in the development of Amantya's AutoRAN. So without further delay, I will now hand over the floor to Indranil.
Thank you, Rohina. Hello, everyone, and thank you for joining us today. So I'll get right to it. Just so that, just a second, please. Yeah, so as a part of the program today, we will walk through the company overview, just one slide and just an introduction. Our paths may have crossed, but for people who are joining us for the first time, I think this would be valuable information. We will then do a quick overview of the AutoRAN, the test automation solution that we have. I'll also walk you through typical deployment scenarios. What are the different use cases that AutoRAN is expected to fulfill? And what are the feature sets that we have, and what are the typical deployment use cases that we need to address. Then we will do a demonstration. A colleague of mine will take us through a short demonstration of the AutoRAN, and finally we'll round this off with the Q&A. So just to kick things off, a brief overview of the company that I belong to. So I am from Amantya Technologies, and we are a product engineering company, but we have a particular penchant for solution development as well, right? So we have essentially three pillars that we kind of focus on towards development of end-to-end solutions for our customers, right? We have some in-house product offerings that we've built, and we call them accelerators. And then we also do a lot of design-led manufacturing. These two aspects, along with our pretty wide professional services portfolio, come together to develop end-to-end solutions for our customers. Some of the product offerings that we have in our stable include a 5G core and a 5G network in a box. The network in a box is a RAN and a core solution all put together into one small form factor. The private 5G solution, which is a sort of small core with third-party RANs that we've integrated together. Then we also have the AutoRAN, which is the subject of this particular discussion. From a solution development perspective, there are various other aspects. There are various areas that we've developed solutions in, ROS applications being, and some of the key areas I have included here as a part of this slide. ROS-based applications, V2X, drone applications, and AR/VR solutions are items that we have worked on quite extensively. On the design-led manufacturing part, mechanical design, hardware design, firmware development, and prototyping and mass manufacturing are areas that we have a lot of experience in. We are a close-knit bunch of about 500 engineers based in offices in the US, Canada, and India. And as you might have guessed by now, our core expertise and core focus area is telecom. And we also do quite a lot of work in automotive and enterprise, as may have been, as is obvious by the product offerings that we have and the solution development areas that we have forayed in. Now we move to the AutoRAN, which is the subject of today's webinar and our test automation framework. Before we actually get down to the nitty-gritties of AutoRAN, perhaps it would be prudent to just take a step back and give you some background, some context as to why we decided to go ahead and build this solution. So, we have quite a few conversations with our customers, and many of those customers are sort of RAN OEMs, mobile network operators, and so on. And some of the items that they keep talking to us about and keep struggling with are sort of distilled and put down in this slide, right? So, what are the drivers that are most critical for RAN testing per se? So one of them typically is comprehensive testing needs. You have multiple types of testing. You have load, soak, you have functionality testing, and all of those things. You have comprehensive and voluminous test cycles. The number of test cases that you have are quite large and are always increasing as more and more functionality gets developed. So those needs need to be addressed. Then there is the problem of interoperability, with the RAN being disaggregated and multiple vendors, multiple technology RANs need to get integrated. There is always a problem of interop that needs to be addressed. Complicated testing setup. RAN testing needs to take care of complex scenarios such as handovers, such as mobility test cases, and with 5G coming in NSA, 4G, 5G interactions, and all of those things. So emulating all of these scenarios in a lab environment typically is a problem and is also one of the challenges that customers keep talking about. Uh, Automation obviously is a problem, and it draws from some of the items that we discussed earlier with respect to comprehensive testing needs and interoperability. Because if the number of test cases increase and the need of the hour is to get multiple releases out quickly, without automation, that essentially is an impossibility, because you need to, the number of test cases are increasing, but the time that you have to actually run those test cases is limited. Apart from that, test management is another important aspect. When you develop a tool, you should be able to have new test cases created easily. Dashboarding, verdict, and log analysis is an important aspect. And finally, there is also the concept of user experience focus. So when you have performance testing, when you want to find out how your RAN's performing in a real world scenario, so that is important. Then how would your RAN perform, not just with emulators, but with real UEs, right? So real UEs play a very important role in ensuring that within the lab confines of the lab, the RAN is performing as it would in a real world scenario. Then there are quality scores also that some customers want for voice calls. For example, for VoLTE calls, MOS scores are almost always requested as a part of the testing exercise. Now, if you distill all of these requirements down, you can get a set of objectives that RAN testing aspires to address, and then a set of implied needs, that you would sort of expect from a testing solution. So what are these objectives? So reduce release cycle times, a no-brainer really. As I said, that when the number of test cases increase, but the amount of time that you have to get a release out, that remains the same. So obviously, that is a problem. It's a dichotomy that RAN OEMs and MNOs typically deal with. Test coverage is important. As you increase the number of functions, as you keep adding more functionality, the test coverage needs to increase to compensate. The number of types of testing. So any particular framework should support different types of testing for you to be able to do all of that while before getting a release out. And not just that, you should be able to mix and match the different types of testing within the same test suite. Technology management is also important as more and more as technology evolves. You have 4G, you have 5G, and all of those things. So the framework needs to be able to evolve to keep pace with the evolving technology. And then a real network. Typically, you would have emulators, but how would your RAN perform in a real network scenario? For that, the testers would need to have real UEs and would need to be able to simulate those real network scenarios within the confines of the lab. So that becomes very important. And the usability aspect, right? How easy it is to use the tool, how rich is the dashboard, how intuitive is the tool to use. So those things also gain in prominence. From that, you have the needs. So the needs are essentially automation, the ability to be able to use real components vis-a-vis emulators, and obviously the operating aspects, which essentially are a simple interface for test case creation. Should have test scheduling ability. You should have the ability to have APIs that can allow you to integrate your tool with an incumbent ecosystem, and support of new technology, seamless support of new technologies as they come into the picture. These are some of the items that we haven't had in mind when we went ahead and sort of uh, uh, designed and developed the AutoRAN. For us, the AutoRAN it's an end-to-end automation and testing framework, and it's specifically targeted towards RAN testing. There are four important components, four important aspects that I would like to draw specific attention to. One is the device side of it, so that the device, instead of using emulators, we use real UEs, which are essentially modems. Then we have an attenuator assembly that sits besides the real UEs. The attenuator assembly essentially feeds from the TX and the RX of the RAN and is used to control the signal power so as to emulate handover and mobility kind of scenarios. On the other hand, we have a pretty comprehensive test management and automation framework. Uh, we support multi-technology in the solution in terms of 4G, 5G, and we are also working towards ORAN at this time. And we also have a very comprehensive emulator package. As you might have guessed that you can have devices on one side, but the network also has a core. And when you're looking at testing RAN solutions with the advent of disaggregated RAN, you could have components that are being tested in isolation, or you could have a system under test that comprises of multiple components. So you could have a CU and a DU being tested together, or you could have just a DU being tested together. In either of these cases, the test topology would change significantly. In one case, you would probably have a core on one side. In the case of the just the DU being tested, you would need an emulator, a CU emulator on one side. So these things led us to believe that just having a single emulator will not be enough. We would need to have an emulator package from which the user can pick and choose. Uh, Three items or three areas that we focused on primarily. From a technology standpoint, we wanted the solution to be standards compliant. So therefore, we've looked at 3GPP and ORAN while developing the solution. Comprehensive emulator support we put in. Right now, we are still in the process of adding more emulators in. At this time, we have NGC and EPC emulators with application QoS data generators as well. But we are going to be adding new ORAN based emulators also as we move forward. Volte VONR support is something that we've included, and also the ability to configure the device under test or the system under test using standards, configuration protocols such as Netcon for TR069. So these are items that we have supported as a part of the solution. Now, from a framework standpoint, you have the ability to create test scripts and organize them into test suites. You have the ability to do results and log management. The results we are able to pull not just from the UE, but we are also able to pull results, logs from the DUT or the SUT, and then analyze them together to generate a verdict. The test framework also allows you to support complex scenarios such as handover and mobility by virtue of the fact that we use emulators and real devices. And we have a comprehensive management interface as well that allows you to run test cases, run test suits. That also gives you a dashboard of which particular test case is running at what time, and allows you to manage your results appropriately. From an operational perspective, we have a set of RESTful APIs, and these RESTful APIs are typically provided on the northbound side so as to be able to give users the ability to control and integrate this solution with their own incumbent ecosystem. For example, if you have a CI/CD pipeline, for example, and you want to invoke various test suites or test cases that you've already integrated and developed within the AutoRAN, then these RESTful APIs would allow you to call these test cases and test suites directly from your CI/CD pipeline, right? All you would need is a simple glue code in between just to invoke these APIs. We've also designed this keeping in mind evolving technology. So our architecture is essentially plugin based, which means that all the message analysis for the different messages that are flowing across the RAN while testing is being carried out, those are all generated and created as a form of plugins, which can be embedded into the AutoRAN framework as and when needed. So if you don't need a 5G plugin, for example, you can simply exclude it, but you can include it very easily at a later point in time. The solution that we offer is an out-of-box offering with hardware and software all put together. So there is nothing extra that a customer would need to sort of go and get in order to start testing. All the solution components that are a part of the solution are pre-integrated, so they just need to be sort of uh, unpacked, set up, and the AutoRAN is ready to go. And it's a scalable solution. The standard offering that we have is 64, but we can scale it to a max of 256 as well. This is a typical setup of the AutoRAN and the way that we would typically expect AutoRAN to be deployed. The items that you see in gray are areas that we provide as a part of the solution. The item in black, right at the center, is the DUT or the SUT. On the left-hand side, you can see a bunch of UEs. So these are essentially real UEs, which are provided in the form of in hardware racks. So you have a rack in which these modems are plugged in, and these modems are connected to attenuators. These attenuators are connected to the TX and RX of the RAN systems. And the attenuators are essentially controlled by the test automation framework. So you can actually write test scripts that can help you decrease or increase the attenuation level, thereby simulating, power getting, thereby simulating a UE that is sort of moving away from the base station or towards the base station. So all of those items or area simulations can be done. And on the right-hand side, we have the core network simulator for end-to-end testing. On the core side, you would have the core network simulator and the application traffic generator. The application traffic generator can help you generate traffic for different kinds of QoS, and so that kind of provides you with end-to-end testing. In the DUT, you will see that we have the provision to test the eNode B. We can test the GNode B, or we can also test the DU and the CU put together. Okay, so an ORAN based system, which is essentially a DU and a CU connected together, the way that the solution is currently, we can test all of this together. This slide focus is a little peek into what we are currently working on. So as I said earlier, we are kind of looking to try and support the complete plethora of nodes and components that the modern RAN system is expected to support, right? So you have the legacy RAN, which is nothing but the GNode B and the eNode B. Now they can run in isolation or they can run together. Okay. If they run together, and then you have the complete box with all of the ORAN nodes, right? So you have the RIC, you have the RU, you have the DU, CU, and these components can also be deployed in a hierarchy. right? So you could have a CU that could be controlling multiple DUs and a DU that could be controlling multiple RUs, which means, and any or all of this could be supported, or the intent might be to test some of these nodes in isolation or together, which means that there is a host of network interfaces that need to be supported, which kind of implies that the number of emulators or simulators that you would need to support also increases. So this is what we are working on right now. We have the as in the previous diagram, we have the modem rig and the attenuator assembly on one side, which can provide you with the real UE experience. And on the right-hand side, we have a simulator package, which the customer can sort of choose from based on what is the scenario that the customer is looking to test, or what is the node that the customer is looking to test. We will be supporting the NGC SIM, and the NGC SIM and the EPC SIM, and the multi-QoS data generator is something that we support right now. The CU SIM, the DU SIM, E2 and X2 SIM, these are items that are going to be coming into the portfolio very, very soon. So this and this solution will allow the customers the flexibility to pick and choose what their DUT or SUT looks like, be able to configure that DUT or SUT within the AutoRAN, be able to choose the different topology based on what is the kind of hierarchy that they want to support, and also accordingly choose the simulators. Uh, and therefore, this we believe will provide a very, very comprehensive sort of testing solution for users when they look to uh, evolve from legacy RAN towards ORAN, and need to test the ORAN together with legacy RAN in isolation, or or in totality. Some of the use cases that the AutoRAN framework is intends to support. Functional testing, that's probably the first item on everyone's list when they look to testing any component. So end-to-end testing for new features and functionalities, either in the legacy RAN or in the ORAN space, is something that the AutoRAN can support. There is the system integration testing as well, where the RAN nodes could be tested with other ecosystem nodes. For example, the E node B could be tested with the G node B in an NSA configuration, or the DU and the CU could be tested together. Or you could have a scenario where the E node B and the G node B are tested together in in a handover configuration, so on and so forth. All of these system integration test cases can be done. Capacity testing is possible from the perspective of generating load mixes for data, for voltage, VONR, for data traffic of different QoSs, to check the performance of RAN nodes and see if they measure up to the kind of performance throughput that they are expected to support in a real life scenario. Stress testing is an offshoot of capacity testing, where you can again generate load mix and then identify issues in the system when you overload the system. Network KPIs. Now, this is a very interesting aspect because typically the RAN supports multiple uh, testing. Typically, it supports multiple counters, right? Multiple KPIs. Now, these KPIs are basically they are derived from the plethora of counters that a typical RAN node might support. And the ability to automate these counters, and the ability to automate the testing of these counters and check whether these counters are actually providing the result that is in conformance with the message flow in the network. That's something that is of paramount importance. Generally, this is done manually, but being able to automate it and also be able to write scripts that allow the automation of such KPI testing, that we believe is of extreme importance and value to people who are, doing testing of RAN nodes. Interworking between 4G and 5G is something that we can do as the current AutoRAN framework supports both 4G and 5G. Mobility testing and handover testing are areas that we have had specific focus on, and we can do that using attenuators, um, where we can increase or decrease the power levels that the UE sees based on attenuator values, and these attenuator values can be controlled using the test case. And in this way, we can actually generate cell edge scenarios, near cell scenarios, mid cell scenarios, and also we can also sort of initiate handovers and test whether the handover works as per expectations. And finally, interface testing, as I said, that we also support a netconf and TR069, so the ability to configure the system, and not just the ability to configure the system. Even in the case of normal test cases where you're doing functional testing, there is always a need to do pre-test configuration, right? And the pre-test configurations are something that you would do with these interfaces that we have supported, depending on what the RAN node supports. So moving on, this here is a high-level feature list of what AutoRAN typically supports today, right? So technology support, we have released 14 support for 4G, and this is from the perspective of the messages that we can typically capture and analyze within the ambit of the overall AutoRAN system. So release 16 for 5G and release 14 for 4G. We support real UEs, which are essentially modems. These modems are put together into racks, and each rack is capable of supporting 16 modems at a time. And our standard offering that we have supports 4 such racks. So our standard offering is giving you 64 UEs, but we can scale the system all the way up to 256 UEs right now. The UEs that we typically offer as a part of the solutions, as I said, are modems or handsets, as the case may be. They are typically 4G, 5G enabled, and would support VoLTE and VoNR at a very high level. Apart from that, we also have UEs that can support things like different categories of LTE. They can also support carrier aggregation and so on. So the point I'm trying to make is that while the capabilities that you see here are standard capabilities that we offer as a part of the solution, but if the needs of the testing infrastructure is something that requires us to deviate from this and be a little more specific to the requirements, we can definitely take a look at that too. From a RAN support perspective, we can support legacy RAN, eNode B, gNode B, as well as the ODU or the OCU put together. ORAN support, of course, we are building in right now. Attenuator assembly, we have an attenuator that is software controlled. So the idea is that you should be able to control this from the test case itself. And it allows attenuation steps of 0.25 dB up to a max of 95 dB. Core emulation support we provide from the perspective of EPC and NGC for VoLTE and VoNR. We are also offering IMS core emulator support. At the same time, we also have included in this in the offering a server-side data generator that can allow you to simulate data traffic for different QoS. And some test framework features as well. So there is a management interface. You can create your own test cases using a script editor that we provide in the framework. And then you can organize these test cases into test suites, and then you can run these test suites. There is a specific interface for test result management also, where you can see the verdicts, and you can actually download. The verdict will essentially provide you whether information on whether a test case has passed or failed, but we also manage logs where you can download a particular log for post-facto analysis. And support for import. So for example, you write a test case using the AutoRAN, and then you want to export it and import it into other AutoRAN systems. So that functionality is also available. We offer message parsing on L2, L3, and NAS messages right now on the DUT side. And we can offer message parsing on on L3 and NAS on the UE side for certain modems. Integration, I did touch upon this briefly. We have RESTful APIs for integration with the incumbent ecosystem. A chief use case among that would be the ability to interface with, let's say, a CI/CD pipeline, where the AutoRAN can be invoked from the CI/CD pipeline directly. The way that we control UEs or the modems is through standard AT commands, which are essentially 3PP defined. So, any modem that supports AT commands can theoretically be integrated into it, but we have tested with a bunch of modems that we offer as a part of the solution. From a logging perspective, as I said earlier a little while ago, we can offer logging on L2 and L3 and NAS for the DUT part, and we can offer L3 and NAS for the UE logging part. Test scenarios, we spoke about it earlier. So functional testing, system integration, capacity, stress, and all of these things we can support. The deployment, the way that we deploy this is we actually provide a rack in which these 64 UEs are stacked, and we also provide a server in which the central framework software runs. All of this is neatly stacked into one rack that we ship along with the overall product, and it can be deployed as is within the premises of the end user. So with that, I would like to move on to the demonstration here. In the demonstration, we will show you what the hardware looks like, and we will point out the different aspects, the different components of the hardware. After that, we will take you through the user interface where a colleague of mine will essentially create a test case for you, run it, and will also show you how these test case logs are generated and how they are analyzed. So that would essentially be the summary of the demonstration that we have planned for you today. So I'll just go to the demonstration.
Hi. So I'm going to demonstrate the AutoRAN physical setup. So AutoRAN have two types of system. One is for a master and another is a rack. So multiple rack is connected with the single master. Uh, if you can see, here is a one master which is connected with this rack. Rack is consist of the 16 real UEs. Some real UEs are connected wired and some are connected with wireless. In this setup, the system under test is Gnode B. Gnode B have a 2x2 MIMO. It is connected to the 4 channel into attenuator. Attenuator is sending the RF to the combiner. Combiner is distribute the signal to the all UEs.
Yeah, hi. So this is our AutoRAN test automation framework dashboard. This dashboard actually allows the testers to control the full automation testing using our AutoRAN. It gives an easy way to actually write new test cases, manage or schedule execution of the test cases, get results, get logs, and get the reports of the various test cases that have been executed. Let's jump onto actually creating a new test case, running the test case and seeing its output. So what we are doing today, we will be running an airplane mode on airplane mode API, which means that we will be registering our device to the 5G network. We will be establishing a PDU session. We will be getting some of the parameters from a particular message, and we will be seeing the results of this. Once this is done, I will be showing to you the DLF or the UE modem logs that have been generated for this test case. We will view these logs on Qualcomm QXDM tool as well. I'll also be showing another unique feature of this tool, wherein we will be exporting these logs into Wireshark, so that in case the developers want to see the RRC messages or different layer messages, we can do that, or those can be shown on Wireshark. Right, so let's start with the particular test case. Let's begin by defining the new test case, and as I mentioned earlier, we will be adding a new test case. So let's provide some description to this. We will call it demo test case. Let's put in some basic description. Demo UE registration. Let's select a category as functionality, and let's select that we want to run this on one UE. Now let's select the APIs from the list that we have. So we will just register the PDU and we will select one particular MZ. Let's now select the next API that we want to run once the airplane mode is on. We will deregister the UE. Let's then run another test case. So the third option is the PDU establishment. So this is what actually helps in assigning the IP address to the UE. Once this procedure runs successfully, let's get the IP address that has been allocated to this particular UE. Now let's try to run this particular test case by clicking on the submit button. This test case has been added, and as you can see on the top line, it shows demo test case. Now we will be running this test case by clicking on the run button. Now what you see on the dashboard itself are the console logs, and of course these are saved in a file as well for analysis at any later point in time. So this was a real-time execution of one of the test cases. Now, as I mentioned earlier, you can add this particular test case in the new test suite as well. Let's create a new test suite. Let's click on the create new test suite button. Now here you can then go and add test cases. So if you recall, we'll just add a functionality based test case suite. And this is the demo test case that we just built. So this is how you can actually create new test cases and test suites as well, and you can actually schedule these to be running at a later point of time as well. So as I mentioned earlier, the UE modem logs, they get generated for the different scenarios that we've executed. As you can see, this is a DLF file that just got generated today, July 26th. And what we'll do today is that we will open this file in the Qualcomm provided QXDM viewer, in which we can then see the individual messages as well. Okay, so this is the QXDM viewer that we have, right? And what we'll do is we'll open this particular file in this viewer. Yeah, so this is the QXDM tool that we'll use to actually decipher and decode the DLF file that got generated. So the DLF file is nothing but the UE modem logs, right? So let's open that particular file and see the contents of that file, right? So as you can see, this is the file that got generated 26th July. So let's open this particular. So as you can see, there are all these different messages from different layers, MAC, and then you have MIBs, which belong to the broadcast channel that contain the system and the cell information, right? And you can get these different MAC TBs information from these QXDM logs. You'll also have certain other messages from different layers within this particular tool, right? And then developers or testers can then actually look at these particular logs to actually figure it out what the problem or what the issue was. So this is just one of the sample ways through which testers can actually debug some of the problems that they may have encountered. As I mentioned, the other facility that we provide is exporting logs to Wireshark and then using the standard Wireshark viewer to actually see those logs, right? So I'll open a sample Wireshark trace as well for you to actually give you some idea on how those logs look. Okay, so as I had mentioned, we also provide the ability to export the logs in PCAP format and then view them using the standard Wireshark utility, right? So this is a sample PCAP that we have. So let me just open this particular file. The reason why you see the filter UDP here is that the way we export these logs, because there isn't a standard mechanism to export and view these on Wireshark, right? So we export these within UDP as data of UDP packets and then see them on the Wireshark. So as you can see, these are again your standard RRC messages, system information blocks, SIBs, SIB2, SIB3, RRC connection setup, RRC connection request, etc., etc., right? So this is again a very useful way of looking at the logs for developers because they're more conversant with Wireshark. So they can then actually look at each and every field of the message and debug what was the issue. So it's a small summary of how teams can use the test automation framework to test Gnode Bs, right? So right from the point wherein they define new test cases, they define new test suites, schedule the execution of these test suites, get the reports, right? And then get the logs in case if there are certain errors that have been encountered. So hope you liked the small presentation that we had set up for the same. Thank you.
Okay, that's I think all we had for today in terms of an overview of the AutoRAN solution and a short demonstration on how the AutoRAN actually works. So over to you, Rohina.
Thanks, Indranil, and thanks for the very interesting and insightful discussion and demonstration. We will now take up the questions. Please share them in the Q&A window, and Indranil will take them up. Okay, I see there are quite a few questions here already. So we'll start with the first question. How does AutoRAN address the unique challenges of 4G, 5G network testing?
So look, 4G, 5G. So let's talk about 4G and 5G separately, right? So with 4G, one of the first things that happened was the separation of the control plane and the user plane, and so essentially what that meant was the increase in the number of interfaces and also the increase in the number of nodes that typically would form a part of the RAN solution. With 5G, that trend has accelerated with the RAN being further broken up into CU, DU, and all of those things, right? So the number of interfaces has gone up, and the number of nodes has also gone up. This has given rise to the fundamental requirement to be able to test each node in isolation as well as the nodes put together, right? So you need to be able to test nodes in isolation as well as the fact that they are working together as a system. Now, AutoRAN was conceived keeping in mind that such a solution, such a scenario would need to be addressed within a testing solution. So AutoRAN provides you with that flexibility where you can choose what kind of node or system under test you have to have. It can choose, it can allow you to choose what kind of emulators you want to use. So that flexibility that the AutoRAN provides, along with the automation aspect and the real devices part of it, that is what makes it uniquely placed to be able to address all of these new challenges that 4G, 5G is throwing up.
All right. Moving on to the next question. How does the framework adapt to evolving 5G standards and technologies?
Can you repeat the question again?
Yeah, sure. Indranil, how does the framework adapt to evolving 5G standards and technologies?
Okay, so fundamentally speaking, the framework that we have developed, it conforms to the standards, right? So release 14 for 4G messages and protocols, and release 16 for 5G messages and protocols. And we are also going to be conforming to ORAN standards when we look at adding in support for the OCU, the ODU, and the RIC part of it. Now, as the protocols and the solutions evolve, one of the important ideas or items that I had alluded to a little while ago during the presentation was the plugin based architecture, right? Now, what this allows me to do is this allows me to create my own dissectors and my own analyzers for different messages as they become relevant for my test case scenarios. And I can keep adding these dissectors and these analyzers without the need to completely let's say reinitialize the software. So as technology evolves, um, I may need to support more emulators because I may need to test more interfaces. I may need to support more nodes. So for that, my emulator package allows me to take care of that aspect. And as let's say protocol evolves with respect to support more messages and more IEs, I can have more support built into my pluggable dissectors and my pluggable analyzers, and have them get embedded into the already existing AutoRAN framework to keep pace with the changing protocols and changing technology. Does that answer the question? Hello?
Yes, I think it does. Moving on to the next question, Indranil. Is there any AWS support to use this stack?
Right now, we are only creating an on-prem solution, right? So it's something that will have to be deployed within the customer premises. Having said that, the solution that we are creating is going to be based on cloud native concepts and principles. So going forward, we may choose to deploy this on the cloud, but right now it's just an on-premise solution. There is no AWS or GCP aspect to it, or any for that matter.
All right. Another question, Indranil, can the solution be customized to suit the specific needs of our organization?
Yes, certainly. Look, there are multiple aspects to it. So the way that you would want to first thing is that the test editor itself can allow you to create your own custom test cases based on what your testing needs are, right? That's the first thing. The second thing is that if you need to support more UEs, because that's what your testing infrastructure demands, you can scale up and scale down. You have an emulator package that can allow you to choose emulators based on your testing needs. And at the end of the day, if you need to build in specific support for different functionality, for example, let's say NB-IoT support, for example, at a later point in time, the code has been written in such a way that you can easily add that as a part of let's say a new functionality library and plug it in. So customization not just from a scalability perspective or functionality perspective, but also from a development perspective is supported.
Okay, I think that should give a fair idea. Moving on, Indranil, next question is, can this framework be used to test ORAN solutions?
ORAN, yes. Look, the way that the solution is right now, we can support a consolidated OCU DU solution, right? So, so if you have so if you have a system under test that comprises of a centralized unit and a distributed unit working together, that can be tested. But if you want to test a node in isolation, for example, the DU or the CU, that we expect to have as a part of the product very, very soon, in about a month or so. We are currently working on that. The other slide that I had shown you, where comprehensive ORAN testing was elucidated. So that part of the ORAN product, that part of the AutoRAN product is currently under development and should be a part of the portfolio in the next 2 to 3 months.
Right. So coming to the last, question, though you have covered it in your presentation, but we'll take it up. Is the solution scalable?
So scalability, from the scalability perspective, from a UE standpoint, yes, it is scalable because you can scale from 64 UEs to as many as 256 UEs, and we are actually working to increase that number even more. From an eNode B perspective, also the solution is scalable. You can right now we can support I think around two eNode Bs, two gNode Bs simultaneously, but that number can also go up. Based on the number of and the testing scenario, you can also add more emulators as and when needed.
All right. All right. So thanks, Indranil. I think we will give
I just saw one more come through right now. So this one is modems. One of our participants is asking whether the modems are USRP based or are Qualcomm chipset like Vectel. So the answer to the question is that they're all commercially available modems, which are based on Qualcomm chipset. Could also be based on MediaTek like Vectel, Telit, Simcoms. Those are the ones that we use.
Right. Fine, Indranil, thank you so much. The way I see it, most of the questions we have answered. I do see a few more. We have noted these and shall be responding to them offline. So with this, we come to the end of today's session. Thank you all for joining us. We hope you found the webinar insightful. Please feel free to reach out if you have any specific queries or interest. You can write to us at connect@amantyatech.com and we can help you with more details and a live demo. And of course, the recording will be available soon for your reference. So do stay tuned for more updates from Amantya, and we look forward to seeing you in the future webinars. Thank you so much. Bye-bye.
Thank you.